Alrighty, guys, we're going to add the last thing to our notebook, actually. I think I have extra lines here. I'm not quite sure why, but that's okay. So the last thing we're going to talk about is quadrilaterals on the coordinate grid. And that's actually like kind of placed throughout our notebook in a little bit of random spots. So really the best place to look is 88 through 91. And we'll talk about a couple of different quadrilaterals there. And yeah, let's dive right in. So if we turn to page 88 first, this is a good place to start because we need a couple of reminders here. Like if I'm graphing a quadrilateral on the coordinate grid, I might want to remember the slope formula, because the slope formula, so like rise over run, or y minus y over x minus x, will tell me if my, well, it'll tell me what my slopes are, but that's helpful because parallel lines have the same slope. So parallel lines have the same slope. So that will tell me if I have two sets of parallel lines, or only one set of parallel lines, or no sets of parallel lines. So it'll kind of determine if I'm a parallelogram, trapezoid, or kite. Also, it's good to remember the distance formula, which the distance formula I like to remember is really that it's the Pythagorean theorem, kind of. So like c squared equals a squared plus b squared, but we'll square root it, where really your a and b are like rise and run. So rise squared plus run squared. Now, again, the distance formula truly is like a crazy x minus x squared plus y minus y squared, all square rooted sort of thing. But that's what I do when I'm finding rise and run. So that's why we can just use those instead. Now, again, knowing the distance or finding the distance is important, because then if I know that opposite sides are the same and I have like two sets, then maybe I'm a rectangle, or maybe I'm just a plain old parallelogram. Or if I find that all the sides are the same, then maybe I'm a rhombus, or maybe I'm a square. So this is going to help me find side length. Now, we might want to use both to determine more specifically what I am, because knowing just the slope, that only tells me if I'm parallel or not. But knowing the distance as well will maybe tell me if I'm a rhombus or not, because then I'll know all the sides are the same. And then it's also helpful to, I don't know why it keeps kind of flashing like that. I don't know if you guys can see that or if it's just my eyes, but like I keep noticing little flashes. It's weird. Another useful thing to remember is how we find the midpoint. And the way that we find the midpoint is we actually like add up the x's and take half, add up the y's and take half. Like that's the true formula for it. But usually what I do is I just do rise over run, but half. So like I find my rise over run, but then I only travel half the distance so that I only get halfway. And that can be helpful because like with the diagonals, because in a parallelogram they bisect each other, the midpoint of one diagonal should be the same as the midpoint of the other. So if I find that, then I know that I'm a parallelogram. But then maybe I can find more things about it too to see if I'm a better type of parallelogram. All right, so let's try a couple. Looking at this first one here, if I plot 0, 0, 1, 3, 5, oh, fartaroo, 5, 3, and then 4, 0, whoopsies. So just like looking at that little cutie right there, let me get a little straight edge. To me, looks like a parallelogram. Anything that's like a slanty rectangle, I always think of as a parallelogram. But it could be better than that. So, I mean, let's just find out if it's a parallelogram or not. So to find out if it's a parallelogram, I guess I'm wondering is AB parallel to DC? And is BC parallel to AD? And so to know, I want to find the slope of each. So the slope of AB is up 3/1. And the slope of DC is up 3/1. And so since they're equal, they are parallel. So that all checks out. Then I also want to check the slopes of BC and AD. So the slope of a flat line is 0. And AD is also a flat line, so 0. Oops, sorry about that. So since they're equal, those lines are also parallel. So at the very least right now, I know that it's a parallelogram. So something that I might want to also consider is like the length of the lines so that I can see if it's just a plain old parallelogram or if it's something better than that. Now, right now, based on the slope of this line being 3 and the slope of that line being 0, I know that it's not a rectangle or square. None of these angles in here are 90, and there's something to do with the slopes as well, which we'll talk about in the next example. That will also tell me if I'm 90 or not, but these are not 90, or maybe you remember from before. So this is all slope stuff. Another thing that I might want to find though is length stuff, because length will also tell me more. Like if all the lengths are the same, then I'm a rhombus, but if not, then I'm just a plain old parallelogram. So if I think about AB, finding the length of that, length or distance I can do by doing rise squared, run squared. And I already have the rise and run. Like I found it up here. So like 3 squared plus 1 squared. Oh my word, can I pause this? Oh my gosh, I can't. Hold on, I'll be right back. Just wherever. Right up here. Whoops. All right, I'm gonna keep going. Oh my God, was that you that texted me?
Yeah, I was like.
I don't know why it. I know. I don't know why it popped up as. It said that it was Kylie. I'm sorry. Anyway, sorry, students in here, ignore me. Alrighty, so I can find the length by just taking rise and run and squaring each one. So, oh my God, that kind of rhymed. See you later, Russ. 1 squared is 1. Then I add them up and square root it, so square root of 10. Now, the super nice thing is because DC has the same rise and run, it's also that length. Now, for BC, I don't really need to do rise and run squared because this is just flat, so I can count how many squares there are. So BC is 1, 2, 3, 4 squares, and so is AD. And so this really tells me that I for sure am just a plain old parallelogram. I'm not a rectangle because I don't have 90s. I'm not a rhombus because all the sides aren't the same. So therefore, I'm not a square either. That was kind of a lot for just one problem. I'm so sorry. Maybe we'll not do all of these. Alrighty, taking a look at this one. You know, this is maybe one we'll skip because we already talked about the distance formula. So let's jump down here and actually look at this midpoint one. Because this is also using slope and distance. So I'm going to maybe leave those two for now. And then if we feel like we need another video of this, I can do that and post it tomorrow or something. So, all right, let's try this one here. So we'll do A is at 3, 3. B is at 1, 2. C is at, oh my gosh, -3. 1, 2, 3, 1. What? And D is at -1, 4. What? Did I plot A correctly? 1, 2, 3, 1, 2, 3. What is going on? Did I plot everything correctly? 1, 2. -3, 1. -1, 4. All right, well, connect them. To me, this looks like it's not going to be any sort of special quadrilateral, but let's take a look at drawing in those diagonals. So if I draw in the diagonal of DB and then AC, one other way I can determine if something is a parallelogram or not is that the diagonals must bisect each other, meaning that their midpoints must be the same. So if I find the midpoint of DB, the pink diagonal, I can do my little formula and take points D and B and like add them up and take half, or I can just count, rise, run, and do halfway. So from D to B is down 2 over 2. So down 1 over 1 puts my midpoint right there, which is at 0, 3. Then if I find the midpoint of AC, so the other diagonal, yeah, I would just count, rise, over, run, and do half. So from C to A, I would have to go up 1, 2 over 1, 2, 3, 4, 5, 6. So rather than doing 2, 6, I'm going to do 1, 3. So up 1 over 1, 2, 3, which even though my line was poorly drawn, that is where my midpoint is, which is at 0, 2. So since these do not coincide, since they are not the same midpoint, that means that this is not a parallelogram, which I feel like I kind of knew by the picture, but it's always important to back stuff up with math. So now I have a backup because their midpoints don't match, not a parallelogram. Okay, jumping ahead to page 90. Actually, let's go to 91 first. We can determine if something is a rectangle, rhombus, or square on a coordinate grid as well. So if we plot this guy right here, -3, -3, -3, +3, 3, 3, and 3, -3. Well, I mean, that little cutie right there sure looks like a square, but the way that I can know for sure, or like rule things out, is to find all the slopes and all the lengths. So the reason I want to find the slopes is because if I have adjacent sides perpendicular, then that means they're 90. And so perpendicular slopes are like opposite and reciprocal slopes. So if I find the slope of each side, AB, BC, CD, and AD, now AB is a vertical line which has undefined slope. BC is a horizontal line that's got 0 slope. CD is undefined. AD is 0. And these are perpendicular to each other because technically like undefined is 1 over 0, which is the reciprocal of 0. So I do know that I have all 90s, which at the very least makes me a rectangle. Okay, so knowing that all my angles are 90 definitely makes me a rectangle. But if I want to be a square, I have to also be a rhombus. So to know that I'm a rhombus, I want to find the lengths of all the sides. So again, for length, I like to do, well, I guess distance equals rise squared plus run squared. Or just count, like in this case, because they're all flat edges, I can just count the length of each side. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So, because all my sides are the same, I'm a rhombus. And so since I'm both, that means I'm a square. So all sides congruent and all angles congruent. Now, as much as I'm sure you guys would love to do a proof again, we are going to skip that bottom part. So let's open this up and try a couple more. Okay, so we're going to do 2 more where we determine if we have a rectangle, rhombus, or square. So if we try this one here, we got -2, 1, -1, 3, 3, 1, and 2, -1. So just based on looking at this, to me it looks like a rectangle, but I always just find slopes and lengths. However, as I'm thinking it through, like maybe let's try a different one. Let's talk about the diagonals. That could be fun. So if I draw in my 2 diagonals here, the super fun fact about the diagonals in a rectangle, if that's what I think this is that they're the same length. So I'm going to find the length of the diags. So if we do BD, I'm going to have to count, rise, and run. So from B to D, I'm going to have to go down 1, 2, 3, 4, and then over 1, 2, 3. So 4 squared plus 3 squared, and then square root it, which is 16 plus 9, which is 25. So the length of BD is 5. Then if I find the length of AC, now that one is just a straight flat line, so I can count it 1, 2, 3, 4, 5. So I can see that the lengths of the diagonals are the same. However, an isosceles trapezoid also has that. And I know it doesn't look like it, but I do have to rule that out. So if I also find the midpoints of the diags and they coincide, that will make it a parallelogram, which is not a trapezoid. So finding the midpoint of BD, I'm going to do that rise, run, but in half. So down 2 over 1.5, which puts me at half, 1. And then the midpoint of AC is going to be right in the middle of that 5 length line, which will be like 2.5 away. So 1, 2.5 puts me in the exact same spot. Okay, so because I know that the lengths of the diagonals are the same, and I have a parallelogram right here, this is a rectangle. I like it. There's so many other ways you could do it. Alrighty, let's try another. So 0, 2, 2, 4, 1, 2, 3, 4. 1, 2, 3, 4, 2, and then 2, 0. That boy looks like a square. So maybe going back to basics, to know that I'm a square, I just need to know if I have all congruent 90-degree angles and all congruent sides. So let's find the slopes of the sides, because that will tell me if they are perpendicular or not. So AB, BC, CD, and DA. So from A to B, I got to go up 2 over 2, which is 1. For BC, I need to go down 2, forward 2, which is -1. and those are opposite reciprocals. So these are perpendicular. Also from C to D, I actually want to start at D, and I would go up 2 over 2, which is 1. So these are perpendicular. And then lastly, from A to D, because A is leftmost, I'd have to go down 2, forward 2. So I get another -1. So all these boys are perpendicular to each other. So I have a bunch of 90s, which definitely makes me a rectangle. So then to figure out that I also have a property of rhombus, so this is definitely a rectangle, checks out. But to figure out that I'm a rhombus, I need to check the length of the sides. So if I do AB, BC, CD, and DA, I already have like my rise and run up here. And like they're all the same. So when I do the square root of rise squared plus run squared, even when the number is negative, it's still going to turn it into a positive when I square it. And so like 4 plus 4 is 8. The square root of 8 I don't know. But they're all going to be that. And so I can see that I have all congruent sides making me a rhombus. And so since I have a property of both, this boy is a square. Okay. Last but not least, let's jump over here and try a couple of these. Am I maybe going to save this? Let's just look at the front. We'll do the front. I just don't want this video to be forever, and I'll save a couple in case we need a second video. All right, determine whether ABCD is a rectangle using the slope formula. So if we plot these points here, -2, 3, 4, 3, 4, -1, and -2, -1. So we actually already did one like this. The slopes of each of these, so AB, BC, oops, sorry, CD and AD have to be opposite reciprocals of each other. But again, these are kind of special lines, and vertical lines and horizontal lines have unique slope. So AB was horizontal, so 0. BC is vertical, so undefined. CD is horizontal, so 0. And AD is vertical, so undefined. And these are opposite reciprocals of each other. So yes, they are perpendicular. Now we can also use the distance formula to prove that something is a rectangle. So is this the same one? Yeah, it's the same one. A, B, C, D. Okay, so using the distance formula, we can kind of do that one of two ways. We can first prove that the figure is a parallelogram. Well, I've kind of already done that because I know my slopes. So because AB is parallel to CD because they have the same slope, and BC is parallel to AD because they have the same slope, I'm a parallelogram. Then what I could also do to show that now I'm a rectangle is, well, like I did it here by showing the sides are perpendicular to each other. So a different way to do it is to determine if your diagonals are congruent or not. It's not enough to show that the opposite sides are the same because like a parallelogram already has that. That doesn't differentiate it enough. And so if I find the length of diagonal BD, I'm going to do the rise squared, run squared. So from D to B, I'm going to go up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6. So 4 squared plus 6 squared is 16 plus 36, which is 52. Which actually I think 4 will go into that. 13 times. So 2 root 13. And then when I try out diagonal AC, when I count from A to C, I go down 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6. So even though it was -4, when I square it, it's still going to be positive. So it's literally the same two numbers. So it's still going to be 2 root 13. So since they are congruent diagonals, I know that I'm a rectangle. Okay, my dudes, just for sake of time, I'm going to stop there. I know we have these examples here and the other ones, but I'll save that maybe for a separate video just in case.